So very good afternoon to all of you. So today we are going to discuss a numerical based upon the hydrostatic force concept within the 10 minutes trick. Okay, so this is the problem to us, and this is one gate is there. So this one is one gate is there, and suppose I am choosing this one as point number A, this is point number B, and suppose this point I am choosing this point is C. So this gate is actually it is contain two types of liquid. Okay, one liquid, this is water, and second liquid, this one is a mercury. Okay, so net depth of the water which is at the upstream of the gate, that is up to, this is 2 meter. Okay, so this distance is given as a, this is 1.75 meter, this is 1.75 meter, and this distance is 0.75 meter, and this distance mercury depth at the upstream of the gate, that is 0.75 meter. Okay, so the gap is kept at a distance, at an inclination of theta will be equal to, this is 30 degree. Okay, and now, and this distance, so this distance is given as this is this is 0.5 meter, and this distance is given as this is 1.5 meter. So this is 1.5 meter. So now we have to find out, is asking, we have to find out the what is the magnitude of the hydrostatic force acting onto the gate, and what is the center of pressure, what is the center of pressure of this hydrostatic force, where this hydrostatic force will act, and what is the magnitude of this hydrostatic force. Let's proceed. So this is my gate. Okay, so this is my gate, and the distance in between already I told you, that is point number A. If you see, this is my point number A, and this is my point number B, and this this point number C, it is at a distance of 0.5 meter from the here, and 1.5 meter from this point number C. And the pressure intensity, if you draw the hydrostatic pressure distribution curve, the pressure intensity at point number B will be this one. What is magnitude? That is 1.75 gamma W. Similarly, if you find out the pressure intensity at point number C, simply rho GH you have to do. So that is how much? This is 2 into gamma W. Gamma W is what? This is rho W into G. Okay, specific weight. So if you join, this is the hydrostatic pressure acting on this region. This region means this is B and C region. Okay, similarly, if you find out the pressure intensity at this point number A, that is coming out to be 0.75 times rho G plus 2 times gamma W. So if you join this one, this is the pressure acting onto this region. So if you want to find out a resultant force, what is the resultant force acting on this gate? Okay, that is nothing but the area of the pressure distribution curve. Okay, if you find out the area of the pressure distribution curve, then that magnitude will be equal to resultant force acting onto this gate. Okay, suppose this is the force, hydrostatic force of this area. If you find out the area of this pressure distribution curve, so this is F2. Okay, and similarly, so this is suppose you find out the area of this curve. Okay, area of this curve, that is suppose F1, and if you add F1 and F2, that is the resultant hydrostatic pressure distribution, or resultant pressure hydrostatic force magnitude, that is FH. Okay, and this is suppose this F1 is acting at a distance of x1, and this F2 which is acting on this curve, pressure distribution curve, that is suppose at a distance of x2, and this is my xp. We have to find out this xp, where it is acting. Okay, so let's proceed. Very simple is that. So now we have to find out this F2, this one is F1. Okay, suppose I am finding out now what is this F1. F1 is what? Area of the pressure distribution curve. Okay, area of the pressure distribution curve, this is the area. Okay, so what is this area? This is 1.75 gamma W plus this is 2 times gamma W divided by this is 2 A plus B by 2 into this, what is the distance? This is 0.5, and this is force means per unit length. Okay, per unit length. So we have to multiply the width of the plate also. Okay, so what is the width is given? This is 3 meter. Okay, so what is this force is coming out to be? The force is coming out to be, this is 2.8125 gamma W. Okay, so we found out the force. So similarly, if you find out the F2 is how much? F2 you can find out the area of the pressure distribution curve. This area you can find out. Okay, So that is how much. So this is 0.75 times specific weight of the mercury plus 2 times gamma W. So we need to convert into one fluid. So I can write it down, this 0.75 into this is 13.6 times this is gamma W plus this is 2 gamma W. So this is coming out to be 12.2 times gamma W. Okay, so now this is 12.2 gamma W plus this is 2 gamma W, area of that one, divided by this is 2 into this is 1.5, and the width is going to multiply 3. So what is this magnitude is coming? F2 is coming out to be, this is 31.95 times gamma W. This is F2. Okay, now resultant hydrostatic force, if you find out the resultant hydrostatic force, that will be what? F1 square plus F2 square plus this is similar 2F1 F2, this is cos theta. Okay, this is square. Okay, so now theta is 0, these forces are parallel to each other, so I can write down this is F1 plus F2 whole square will be equal to Fh whole square. So what is the hydrostatic force? This simply we can add it, F1 plus F2. So what is this F1? F1 is, this is 2.8125 gamma W plus this is 31.95 gamma W. So if you add, the resultant force is coming out to be 34.7625, this is gamma W. This is the hydrostatic force magnitude acting on this gate. Next we find out what is the XP, where it is acting. Suppose this F1 is acting at a distance of x1 from this one, and this F2 is acting at a distance of this x2 from this point number A. Okay, point number B suppose. Okay, and now we have to find out what is this XP magnitude. Very simple. So we have to take the moment about this point, particular moment. So XP we can find out, this XP will be equal to, this is F1. Okay, so this is F1, suppose this is my force F1, this is my force to F2, and this is my force Fh. So F1 and the perpendicular distance is how much? This is x1. So F1 into x1 plus similarly F2 into this is x2. Okay, this is F1 into x1, this is F2 into this x2. Okay, x2 we have to find out. Okay, F2 into this is x2 divided by this is hydrostatic force. This is the things. Now we have to find out this x1, the centroid of the pressure distribution curve. This we have to find out centroid of this pressure distribution curve, this one. So x1 will be what? x1 will be centroid of the trapezoid. Okay, x1 will be, that is 1.75 times plus 2 times this is 2. Okay, divided by this is 1.75 plus 2 into this is how much? 0.5 by 3. Okay, because centroid of the trapezoid is how much? This is a plus 2b by this is a plus b into this is h by 3. Same thing I have done here. So this x1 is coming out to be, this is 0.255 meter. Similarly x2, if you do, x2 will be how much? x2 will be, first we have to find out this distance. Okay, first we have to find out what is this distance. So let's find out first this distance. Okay, this distance is how much? Centroid of this. Suppose I am taking this one as x3. Okay, so let's suppose this x3 is centered of this pressure distribution, x3. Okay, let's x3 will be equal to, that is 2 times plus this is 2 times 12.2 divided by this is 2 plus 12.2 into this is how much? 1.5 by 3. So how much it is coming out to be? This is 0.9295 meter. Okay, so now we need to find out this x2. Okay, we need to find out this x2. Okay, we need to find out this x2. X2 will be how much? This is 0.5 plus this one. So x1 is how much? X1, this is 0.255 meter, and this x2 will be how much? So 0.5 plus this distance, that is x3. X3 already found out, this is 0.9295. Okay, so we find out F1, F2 already find out. Can you find out this XP? Yes, we can find out. So this XP is coming out to be, so the F1 into x1. F1 is how much? F1 we already found out. this is 2.8125, this is gamma w, into this x1 is 0.255. okay, so this is already found out, plus f2 into x2, f2 is how much, this is 31.95, this is gamma w, okay, into x2 is how much, this is 0.5, plus this is 0.9295. okay, so divided by this hydrostatic force F1 plus F2, that is how much, this is 34.7625 gamma w. So if you solve this one, this xp is coming out to be 1.335 meter, 1.335 meter. So this xp you got, this is 1.355 meter. But we need to find out what? But we need to find out this one. We need to find out, suppose we find out our hydrostatic force is this one, okay, this is hydrostatic force, and we find out this distance, okay, this distance we find out xp, okay, but we need to find out from the free surface, what is the free surface, ycp, this one we need to find out, this distance we need to find out. What is this ycp? Because this xp is there, okay, this xp is there, this is already find out, and this xp is already find out, and this angle will be 30 degree. So can you find out this distance, this distance? So this ycp will be, I can write it down, the ycp will be equal to, this is will be equal to 1.75 plus this is xp sine 30 degree, because this distance, so this distance, if you say use the sine angle, this will be equal to xp into this is sine 30 degree. Okay, and this one is already given to us, this is 1.75 meter. Okay, so if you put this one, this ycp is coming out to be, that is 2.417 meter, 2.417 meter. Okay, so this is the case. So already find out the hydrostatic force xp, and we convert xp into ycp. So this is the thing, already we have solved this one. Okay, so the thing, so thank you all. Okay, so thank you, and if you like my video, please like and share this one, and please subscribe it. Okay, and you can download this PDF from the description part. If it is not available, you can contact me. So thank you all.